Hello and welcome to this video on simple ionic compounds. This should be a review from Science 9, but if it's not, that's okay. Today we're going to talk about elements and compounds, reading the periodic table, atoms versus ions, and ionic compounds, naming and writing simple formulas. The next video will cover more complex formulas. So you're going to need a piece of paper, a pen or a pencil, and a periodic table for this lesson. So pause this video right now to go grab those things if you don't have them already. I will wait. Okay, I hope you have all of those things. After this video, there's going to be an assignment for you to do. I'm also going to give you a password. This is my way of knowing if you watched the video or not. You need to enter it on the assignment. So matter is classified in different ways. Everything around you, including you, is made of matter. We're going to be talking about elements and compounds in this class, which you can see from the picture on the right are called pure substances. That's because every single particle of that element or compound looks the same. Elements are made up of just one type of atom, and these are the things you see listed on the periodic table. Compounds are made up of atoms from two or more elements. Okay, so let's review the periodic table real quick. This is the one in the back of your textbook. The periodic table organizes all the elements. The metals are in blue, and they're on the left. The nonmetals are in yellow, they're on the right. The semi-metals are in green. Sometimes these are called metalloids. Don't really worry about these for grade 10, but they have properties of metals and some properties of nonmetals too. Everything on Earth is made up of different combinations of these elements. What can we get from the periodic table? So it gives us information on the different elements. What do we need to know? It gives us the chemical name, it gives us the chemical symbol, and it gives us the ion charge. Remember, atoms are neutral and ions have charges. So here's a sodium atom. The symbol would be Na. The charge is neutral because it's an atom. Its ion charge is +1. So if you have an ion of sodium, you would write it as Na+. Scientists are kind of lazy and they don't write the 1 usually, but its charge is +1. Here's calcium. What do you think its atom charge is going to be? Yes, because it's an atom, it's neutral. A calcium ion is Ca2+. You can tell from the ion charge in the corner. The charge is 2+. What about fluorine? A fluorine atom is written as F. Its charge is neutral. A fluorine ion is written as F-. Its charge is -1. Last of all, here's nitrogen. A nitrogen atom is written as N. Its charge is neutral. And it is it's written as N3 as a nitrogen ion, N3-. Its charge is -3. So I'm going to get you now to pause the video and write down the chemical symbol and charge for these ions. So pause the video here, give these a try. When you're ready for the answers, press play. Okay, how did that go? Let's look. So a magnesium ion, you'd write Mg+. Sulfur ion is S2-. A cesium ion is Cs+. An oxygen ion is O2-. You could also write -2 instead of 2-. Either one is fine. Sometimes metals can have more than one charge. So these are found in the middle. These are the transition metals. They're called multivalent metals because they can form different ions. We're going to talk more about them in tomorrow's lesson. So remember, there are two types of compounds, ionic and covalent. So what do you remember about ionic and covalent compounds from your last science class? So first of all, ionic compounds, they're made of a metal and a non-metal. They have ionic bonds. In an ionic bond, electrons are transferred from one element to another. So here's an ionic bond where an electron is transferred. Metals transfer electrons to non-metals, never the other way around, always a metal giving to a non-metal. So there's my metal giving it to a non-metal. Metal ions have positive charges. A fancy word for this is a cation. And then non-metal ions have negative charges. That's because they are gaining a negative electron. The positive and negative charges are attracted to each other. So you've probably played with a magnet before. That's the same kind of bond that you see in an ionic bond. So they're attracted to each other and they hold on to each other. Yeah, they're kind of stuck together, but you can break them apart. When we write the name of an ionic compound, metals are always written first and non-metals always come second. So for example, here's NaCl. We're going to look at our periodic table and see that Na is sodium, Cl is chlorine. So its name is sodium chloride. So here's the tricky thing to remember. The first part of the name is just the metal ion. The second part of the name is the negative or non-metal ion. And it always ends with IDE when you take a non-metal. Okay? So for the non-metal ions, if you have, for example, fluorine becomes fluoride, chlorine becomes chloride, etc. Okay, so if you had an ionic compound formed from lithium and oxygen, it would be called lithium oxide. Calcium and fluoride becomes calcium fluoride. Magnesium and sulfur becomes magnesium sulfide. Sometimes you'll see sulfur and sulfide spelled with a PH instead of an F. That's totally fine. It's just a regional difference. Rubidium and bromine become rubidium bromide. Potassium and phosphorus become potassium phosphide. Okay, I'm going to get you to pause the video again and give these a try. So pause here, press play when you're done. Okay, how did that go? Here are the answers. Calcium and oxygen is calcium oxide. Potassium and sulfur is potassium sulfide. Sodium and chlorine is sodium chloride. Beryllium and bromine is beryllium bromide. How'd you do? Okay, now I'm going to show you how to write formulas for ionic compounds. So ions have charges, but the overall ionic compound is neutral. That means that we write the positive ions first, the negative ions are written second, and some have small numbers called subscripts. So here we have Al2O3. The aluminum is the metal positive ion. The oxygen is the negative nonmetal ion. The purple numbers are called subscripts. I'm going to show you how to get those. So, like I just said, ions have charges, but the overall ionic compound is neutral. That means that the positive charges from the metal have to balance out the negative charges from the nonmetal. So for example, if we have calcium chloride, calcium has a charge of 2+, chlorine has a charge of 1-. So to balance out that 2+, we actually need 2 negatives. 2 chloride ions are needed to balance the +2 charge from the calcium. So now our formula tells us how many of each ion we have. So we have 1 calcium and 2 chlorides. So our formula is CaCl2. So notice there's a little 2 telling us there's 2 chloride ions. All right, let's try another example. Here's sodium. Sodium ion has a charge of +1. Here's chlorine. Chloride ion has a charge of -1. So the total charge +1 plus -1 is 0 or neutral. We don't need to add any more ions here. So our formula is NaCl. That's table salt. Here's aluminum sulfide. Aluminum has a charge of 3+. I know that because I just looked at the periodic table. Aluminum's number 13. Here's sulfur, or sulfide when it's an ion. It has a charge of -2. Okay, so how are we going to balance these out? Well, we're going to use a little bit of math, nothing too hard. you know that there's a +3 and a 2 minus. The lowest common multiple of 3 and 2 is 6. So we're going to try and get 6 positives and 6 negatives. So how are we going to get 6 positives? We need 2 aluminum ions to make a +6 charge, because 2 times +3 is +6. So what are we going to do for sulfide? We need 3 sulfide ions to make a -6 charge, because 3 times -2 is -6. There we go. There's 3 of them. Now the charges are balanced out and our overall compound is going to be neutral. So our formula is Al2S3. Are you ready to try? Pause the video here, give these a try, and press play when you're done. Okay, how did you do? Let's look at the answers. Here is silver bromide. The formula is AgBr. Magnesium fluoride is MgF2. Calcium oxide is CaO. And sodium oxide is Na2O. And that's it. Now you can write the names and formulas of simple ionic compounds. So go to your teams and complete the assignment.